Okay, let's try this again. Hopefully everybody can hear me a little bit better than the first go round. Let's talk a little bit about domain and range when it comes to the graph of a function. Okay? Domain is considered to be the complete set of inputs that make the function work. Now you want to go ahead and write that down. If you need to pause it, go ahead and pause it. But by work, what I mean is that when you put those inputs into the function, you get a real output, a real number that's an output. Okay? A real output. So there are some values in this particular graph that if I went to put it into the function, whatever it may be, an x value, you wouldn't get an output. Okay, for instance, an x value of negative like 6 is down in here. Well, if you put negative 6 into this function, there's nothing here where negative 6 is for the graph, so that means there's no y value for that x value. Okay? Where do we have x values that actually work? Well, that's going to be x values where they have a corresponding y value. And that's what ends up making the graph what it is. So domain, when we think domain, you want to think in terms of x values. And you also want to think in terms of the x being this axis. So when you think domain, you got to think left and right. Okay, where does this thing exist when it comes to the x-axis? Now some people, they'll even take and they'll put like a dotted line in there. Like, okay, there's a kind of a dotted line right about here. Whoops. I want to move the line, not the whole graph, okay? There's a dotted line about right here where the graph stops. It doesn't go any further to the left. So I don't have any x values that work to the left of that. Other people say, you know what, that dotted line is just going to blur things for me, so I'm not going to put it, which is fine too. Let me move this graph back over. Oh, I don't want to move that. Oh, geez, now I'm really making a mess. Okay, that's better. All right, so somehow, some way, we have to be able to say that x values for this particular graph work from here over to here and on to infinity. We have to find a way to say that. And the way we're going to say that is by using notation to show where those x values work. So the first way we're going to talk about, I'm actually going to go from the bottom up. Let's talk interval notation. Well, you know what? No, let's go from top down. So let's talk about inequality notation. Inequality basically says you're going to have a greater than or you're going to have a less than in your little statement here. And for me, I can see that my x values start right here at -1 and go on and on this way all the way up to infinity. All of those x values work, but nothing to the left of that works. So x is going to be greater than or equal to -1. And remember, the point -1, 3 is right here. The -1 is my x value. The -3 is my y value. Okay? So that's why I'm dealing with the -1 and not the 3. So my domain says that the x value has to be greater than or equal to -1. Those are the ones that work. Now, how do we write that in set notation and interval notation? Well, let's jump down to interval notation. Interval notation is basically saying, hey, tell me what the interval of x's is that actually works. Now, once again, those x's essentially start at -1 and go on and on and on forever to the right based on what we see here. So, considering that case, we're going to start at -1 and go, I'm going to put a comma, and I'm going to go all the way up to infinity. And infinity is like that sideways 8 looking thing. All right? Now, what do I put around that? Well, you're going to have one of two options. You're either going to put a parentheses or you're going to put a bracket. Side note, we use parentheses when the point that we're dealing with, in this case it's this point right here, the point -1, 3, if that point is filled in point, that means we're including -1, so we have to use a, oh, I'm sorry, I had that backwards. What am I doing? Let me move this down. When we have a filled in point, that's when we use a bracket. When the point is open, which you'll see in some other examples like that, that's when you're going to use a parentheses. So in this case, because it is a filled in point, I'm going to use a bracket here. And when we have an infinity, we always approach infinity, but we never actually touch infinity. So we aren't going to include infinity, we're going to approach it, so that for that reason we'll use a parentheses. And you're going to use a parentheses anytime you see an infinity or a negative infinity. Okay? So now how does this look as set notation? Well, set notation is a lot like interval notation and something like inequality notation, a combination of the two. So you always do set notation by opening up with a set marker. A set marker looks like that. And then you identify which variable you're talking about. Are you talking about the x or are you talking about the y? In this case, we're talking about the x, and then you put this vertical line, and that's, you say that as x such that, and now you kind of want to use your interval notation. And your interval notation says basically we went from -1 up to infinity. Somewhere in between there is an x. Now you can get into the habit of just putting a less than and a less than, because basically that's saying that x is less than infinity, but x is also greater than -1. So we call it trapping the x. The x is trapped in there. And if you are including either of those, so if you are including -1, which we are because of the bracket, then we also include an equal to sign. But if you're not including the value, which in case the infinity sign, we're not including the infinity sign. So in that case, we don't put an equal sign. We just leave it as a less than. And for set notation, we close it out by closing the set. So you can see that set notation, which is basically this part here, is sort of a combination of interval notation with some inequality notation mixed in with it. Okay, let's look at the same graph, the same function, but instead we're going to talk about the range. So what about the range of this? Well, the range is the complete set of outputs that the function can produce. So the set of outputs. Outputs are also considered to be your y values. Okay, here's my y-axis. That's not my y-axis. Let's move that. Here's my y-axis. So when we talk about the range, we're talking more about the up and down of the graph. How high does it go? How low does it go? Okay, whereas the domain is the left and the right. I don't know if I said that on the previous slide, but you know, your domain is basically left and right. How far to the left does it go? How far to the right does it go? Range is up and down. So once again, we are using this point -1, 3, but now I'm more worried about the y value. In this case, my y value is 3. And from there, it just goes up. So for my interval notation, I'm starting at 3, comma, and I'm going up to infinity. Now I know it looks like this line is really starting to flatten out, but this thing does continue to go up, even though it looks like it's not going to. Think about what infinity is. Infinity, I mean, it's going to continue going to the right. It's slowly going to continue going up. But unless you have a dotted line there that's saying, hey, this thing stops, it does not go across this line, then you know it continues to go up. Now, once again, we're going to use a bracket because it's a filled in dot there at 3, and I'm going to use a parentheses with infinity. Okay? Inequality notation is going to look like this. Now remember, we're talking about the y values now. So we're going to have y is greater than or equal to 3 because it starts at 3 and it just goes up from there. Set notation will be a combination of the two. So set notation is going to be open the set, y such that the y falls in between the infinity sign and the 3. We'll use our less than and our less than. And if we're including either of those two, the 3 or the infinity, then we're going to also put an equal sign. We're including the 3, so we're going to include the equal sign there. And then we're going to close that set notation. Let's do one more with both. Identify the domain and the range. So the domain and the range for each of these. Domain and range. Domain and range. Okay. So now, this is kind of cool because there's not going to be any infinity here because there's no arrows at the end of this line. So what I'm going to do is, I'm going to go ahead and I'm going to look at the domain as my x values. Domain are my x values. Forget about the other two for now. Domain are my x values. And it looks to me like the very leftmost point for this is -4. Let me take this parentheses off. We'll determine that in a minute. So my very leftmost point is -4. It goes up to a +9. Those are my x values. If it's an open circle, I'm going to use parentheses. If it's a closed circle or closed point, I'm going to use brackets. Well, it's closed at the -4 and it's open at the 9. Okay? Set notation is going to be open the set x such that the lowest point is -4, the highest point is 9. We trap the x in between. We use a less than and a less than. And if we're including either of those, we'll also include the equal sign. Well, we're including the -4, so we'll put an equal sign there. That's set notation. Now, inequality notation in this point is pretty much going to be the same thing because we can't just say, you know, x is greater than 4 or x is greater than 9 or whatever, because it's actually the x is trapped in between those two. So I can pretty much copy that down from my set notation. The range is dealing only with the y values. So the lowest y value, whoops, I don't want to put a parentheses there. The lowest y value is -2. The highest y value is 6. I'm including the 6 because of the filled in point. I'm not including the -2 because of the open point down there. So when I do this in set notation, I open the set. Now I'm dealing with the y values such that I'm going from -2 up to 6. I'm going to trap the y in between, less than, and if I have a closed-in circle, a closed-in point, then I also include the equal to sign. The closed-in point is there with the 6. So I close that off as a set, and then I'm just going to kind of copy that up here for inequality notation. I will tell you this, is that as we move forward and as I ask you to practice these in class, the one that I really want you to be able to show is interval notation. It's easier, I know. That's the one we're really going to stick with, but I have to expose you to the other few.